this example, we are going to evaluate the Laplace transform of the function cosine t multiplied by the unit step function t minus pi. So in this case, the a equals pi. And from the second translation theorem, the Laplace of the function t minus a multiplied by the unit step function t minus a equals e to the negative at multiplied by f of s. So for this case, the function cosine t is not in the form of the function of the t minus a. So we're going to use the consequence of this second translation theorem that the Laplace of the g of t multiplied by the unit step function t minus a equals e to the negative at multiplied by the Laplace of the function g of t plus a. In this case, our gt is the cosine t. So then the g of t plus a, which is the g of t plus pi, is the cosine of t plus pi. So then the cosine of t plus pi, we apply the formula of the cosine of the sum from the trigonometry course as cosine t times cosine pi minus sine t times sine pi. The cosine at pi is negative 1. The sine at pi is 0. Then the g of t plus pi is in the form of negative cosine t. Now we are going to put together as we use the second translation theorem. So then the Laplace transform of the cosine t multiplied by the unit step function t minus pi is in the form of e to the negative pi t multiplied by the Laplace transform of the g of t plus pi. As the g of t plus pi is negative cosine t. So we just use the constant multiple property. So negative is pulled out to be the coefficient. So negative e to the negative pi t multiplied by the Laplace of the cosine t. And the Laplace of cosine t, or from the theorem that the Laplace of the cosine kt is s over s squared plus k squared. So in this case, the k equals 1. So then we obtain the solution as negative e to the negative pi t multiplied by s over s squared plus 1.